So welcome supply chainers. So my name is Sergio Caballero. I'm a research scientist here at MIT Center for Transportation and Logistics, and I'm also the course lead of SC0x. So in the past, we had Dr. Ima Borrella as a course lead, and I want to thank her for all the work that she has done for the course. So here with me is Akash Raikangard. So he is the teaching assistant for SC0x. So welcome to this live event, Akash.
Thanks, Sergio. Great to be here. Welcome, everyone, wherever in the world you are.
Okay, so welcome to this second live event of SC0x. So remember that this is the second, and we'll have one additional. So the plan for today is the following. So let me share my screen. And what we want to share with you in the next minute is the following. So basically, we're gonna be talking about specifics about the pace. So the final exam is approaching so fast. So I want to make sure that you are getting prepared for the final exam. Then talking about some tips about how can you get ready for this final exam. And then we specifically, we're going to be talking about the preparation for the module number 3, which is about statistics. And particularly, we're going to be discussing about confidence intervals and also hypothesis testing. So that's the plan for today. So in the meanwhile, if you have any questions, please use the chat to input your questions. So we'll try to answer as soon as we can. Okay, so but please don't miss this opportunity to ask any questions about this topic about statistics. Okay, so let's get started. So as you might know, so in this course we have in SC0x supply chain analytics, we have structured the course in 5 different modules, from module 1 to module 5, and each module requires different times in terms of the number of videos that needs to be watched, and also in terms of the practice problem that they require. And what you see in the bubbles is the time estimate of what we expect you should be spending in these modules. For example, module 1 requires roughly 12 hours between watching the videos, answer the quick questions, and also some of the practice problems, and also the test your knowledge sections. And depending on your background, so this is an average, but so you might spend more or less time depending on your background. So we are now 6 weeks left from our final exam. So our final exam will get released on December 11. So it's really time to start thinking on getting prepared for the final exam. If you haven't started watching any of the material, so that means with the time remainder, with 6 weeks remaining, so that means that you should be spending roughly, in order to cover the 5 modules, between 12 and 13 hours a week, okay, on average. So it's time for you to get ready, start getting ready for the final exam, okay? So what else? So some tips in order to help you to get ready. So there are a couple of things that you can do. So for example, you can start working, so after watching the videos and practicing with quick questions, you can start looking to the module test. So we have one module, so one test for each of the modules. So in this sense, we have 5 of these module or these tests, and basically the intention of these tests is to for you to assess where you are. So these 5 module tests gonna be open until December 11, which is the day when we open the final exam. So you still have some time to work on these problem sets. And remember that these problem sets, these test your knowledge sections are graded. So, and they are worth it 10% of your final grade. The remaining 90% is gonna be your final exam. But please do these test your knowledge sections. Then we have the exam prep section. So we'll have 3 different problems for these sections. We already released 2 of them. The first one was related to module 2, probability, and the second one is related to statistics. So basically, what the live event that we are having is to guide you through this exam prep section. And the last one is going to be released next week. So it's going to be released November 6th. And we also have linked to this exam prep section a live event. So our third live event is going to be November 12th, and the focus of this final live event is going to be about optimization, which is our module number 4. Okay, so we are right in the middle, starting the second live event. So please don't miss the opportunity to get prepared for the final exam and take a look to these exam prep sections. And finally, we'll also have some practice exam. So the idea of this practice exam is to simulate the exam environment. It's going to be exactly the same conditions that you will have in the real final exam. And this practice exam will be available on November 20, and it will be available for about 3 weeks. So we will close this practice exam the day that we release the final exam. So this is another chance for you to get ready for the final exam. As you know, the final exam will be released on December 11th and will be available for 1 week. So it will close on November 18th. However, you will have only 4 hours to complete the test. So once you start and when you click on, you may click on the start, you will have only 4 hours to complete the test. Okay, so that's some of the key things that you can do for get prepared for the final exam. As I was saying, one of the options is the exam prep sections. So I mentioned that we have 3 problems there. The second one is about our third module, about statistics. And here what we have is 3 things, 3 components. First one is the problem statement, where you can see what the problem is about, and also you can find the questions, and also you can work on that and input your different questions. So this is all the narrative about the problem that we are trying to solve. That's in the section, the first part of this section, and it's called for you to solve. Then we have a step-by-step solution. So after you try by your own, so we'll provide also the answers, but in this case, it's a step-by-step solution. In this case, Ima solved this problem and will guide you a step-by-step in order to solve the different questions of the problem. So if you try and you didn't get the final result, or if you want to verify your results, go to this second step. And finally, we'll have the live event. So that the live event that is linked to this problem. So the idea of this live event is to answer any question that you may have in this process when you were trying to solve the problem. And also we'll try to guide you in some of the high level approach, but the idea is not to solve the problem again, because that was already solved by Ima in the step-by-step solutions. Okay, so that's the main focus of this live event, to solve any questions, any particular questions that you may have about this module about statistics, and particular about the problem that has been posted. Okay, so let's now talk about the problem itself. So in this case, the problem was the problem that was given for you to solve was a problem in which we are trying to analyze the last mile delivery, and the data that was shared with us was 2 data sets. From on one end, we have the promised delivery date, and on the other side, we had the actual delivery date. And we are trying to analyze what the difference between these 2 data sets are. So basically, we are computing the difference between what we promise and what we actually deliver. And this is a data set that is composed of 136 observations. So this is our sample size. So we have 136 data points in our data sets. And these 136 data points is just the difference between what we promise and what we actually deliver, measuring number of days. So we also had, was given for this problem, the mean. In this case is the mean of these differences, and the mean is 16.25. And finally, the standard deviation, again, of the observation, which are the difference between the actual values and between the promised values and the actual values. And for question number 1, we were asked to to compute a 90% prediction interval and a 90% confidence interval. Okay, so the first thing is let's work on the prediction intervals. And in this case, what we are trying to compute here is is an interval, a prediction interval. And what we mean by interval is just a set of values, and this set of values are bounded by the specific values. So this is what we need to compute, the bounds, the limits of this interval. Usually we will have a lower bound and we'll have an upper bound, and this is what we really need to compute. In the case of the prediction interval, so these bounds will tell us what is the probability of a point to fall within these bounds, and the way to calculate is just using the sample mean, so the sample average, which is x bar, then the standard deviation of the sample s, and also we have to compute the c, and this is going to be based on a standard distribution. Standard distribution. In a similar way, we are asked to compute the confidence interval, and in this case, this confidence interval, as before, is going to be an interval. But however, the main difference here is this interval is not for specific values of the data points. It's an interval that we are trying to build for the true mean, for the mean of the population. Because you might remember that all the data that we are working on is sample data, but if we can infer, so what would be the real or the true mean of the whole population? In that case, we have to construct a confidence interval, and the formula is here on the screen. So basically, we need similar information. Again, we need the mean of the sample. Then we need the standard deviation of the sample in our case of observation. For the difference, we again need to compute the C based on the standard distribution. And now something that we introduced for the confidence interval is also we need also the sample size, the N. So how many observations do we have in the sample? So that's the formula. You can see that the lower bound and the upper bound are similar. The only difference between them is that in the first case, you are using a minus sign, and the second one, you are using a plus sign. So basically, first one is going to be the mean minus a specific value, and the upper bound is going to be the mean plus the specific value that we have over there. Okay, so usually, so we have to compute X and S in this particular problem that was already given. So what happened with C, or the value that we need from the standard deviation? And that also should be computed. And usually information that we need in order to compute this value is the confidence level. And the confidence level is going to be something that usually is a user input. And for this kind of problems, that's going to be also given. And typically the values for this confidence level are 90%, 95%, or 99%. So that's what you need, that information that's going to be given. Based on this information, you're going to be computing the alpha. So basically this confidence level is going to be 1 minus alpha. So 1 minus alpha is going to be 90% or 0.9 or 0.90. Based on this confidence level, you will compute the alphas, or the alpha over 2. So if, for example, we are trying to construct a 90% prediction interval, so 1 minus alpha is going to be 0.90, and alpha is going to be 1 minus this value, so it's going to be 0.1. And so I have alpha over 2, it's going to be 0.005. So that's what we need in order to compute the C. So basically, I think Akash will clarify questions. What's the value that we need to input there? Okay, so that's typically we use in the past when I was at school, we tend to use used to use tables in order to compute or to get these values, but now you can use Excel, and for different values of alpha you can get the C. So please use Excel in order to get this C. Once you have the C, the value of the standard distribution, you can plug in your formula, and you will get the prediction and the confidence intervals. In the case of the problem that you were meant to solve, so for the 90% prediction interval, we have the values. So the mean was 16.25, and this was the formula that we use. Again, the mean was 16.25 and the standard deviation 8.83. And we compute using the 90% confidence level. Using this formula, we compute the C, and then we plug those values in the formula. So at the end, the prediction interval is, or the bound for this interval are 1.7. So that's going to be my lower bound, and 30.8. That's going to be my upper bound. So basically, what we're doing is replacing all the values in this formula. So we've got X bar, we got C, S, and we also got C using the normal, the norm S inverse formula in Excel. In a similar way, we construct the confidence interval for the true mean, but now the formula is a bit different. So now we have to introduce the sample size. Again, we're using the same value for C, because the alpha is exactly the same, and based on these values, we are computing the upper and lower bounds of my confidence interval. In this case, the lower bound is 15, and the upper bound is 17.5. So the interval goes between 15 up to 17.5. So my true mean, so the probability of my true mean being between these values is going to be 90%. So 90% of the times, I'm going to be having a true mean that's going to be within those values. So that's question one, talking about prediction intervals and confidence interval. When trying to estimate what's going to be the probability of having a point within the prediction interval, or the probability of having the true mean within the confidence interval. Okay, do you have any questions for this part, or not yet?
No, yeah.
Akash. Okay, so I will continue, and I will get back to if you have any questions for this particular question. So the question two was a bit different. In this case, different but similar. I'm going to explain why. But basically here, what we're trying to assess is the difference of work methods. So they are now using a different evaluation method for the suppliers, and they are having different delivery dates. So basically, I'm trying to assess if the introduction of this new method had some impact in the supplier's delivery date. So basically, so we have some old method, we work in some way, and we did something, and the delivery time changed. So basically, we want to assess if the difference that in the delivery times that we are getting now are due to this method, and that required what is called a hypothesis testing. And for this hypothesis testing, the information that we have is similar to what we have for question one. Again, we have a sample, so we don't have the information for the entire population. We have just a sample, and this particular sample is composed of 138 different observations. So those are my data points. And again, my data points are the difference between what I'm promising, so the promise date, and the actual date. So the mean of these differences is 21.38, and the standard deviation is 10.56. Again, this is the mean and the standard deviation of the sample that is composed of these 138 data points. And the previous mean, so before implementing this new working method, the previous mean was 20.31. So basically, there's a difference. So between 21, so the new mean, and 20, the old mean. So we want to assess if this difference of maybe 1.07 is significantly different or not. Okay, significantly different from 0 or not. Okay, so that requires an hypothesis testing, and this hypothesis testing will have some part, but basically we'll have we need to define two hypotheses. The first one is what we call the null hypothesis, and this hypothesis states that nothing has changed, And we cannot reject this unless we have enough evidence to do that. So basically, with this hypothesis testing, what we're trying to look for is for evidence in order to reject this hypothesis testing. But if we don't get enough evidence, so we cannot reject, and we will be failing to reject this hypothesis, this null hypothesis. Then we have what is called the alternative hypothesis. And I'm going to be explaining what that is. So basically, but the main result is going to be, if result or the main decision is going to be, we reject the null hypothesis or we fail to reject the null hypothesis. There are different steps to conduct a hypothesis testing. First, we have to formulate the hypothesis, basically the null hypothesis and the alternative hypothesis. Then we're going to be working on selecting test statistics. And basically, to decide on the test statistics, we have to ask us a question. And the question is related to the sample size. If we have a sample size more than 30, so if we have more than 30 observations in our data set, we can use the normal distribution. But if we have less or equal to 30 observations in our sample, we can use the t-student distribution. So the first question here in this second step is, how many data points do we have? So what's the size of my sample? What's the size of my sample? And the break point is going to be 30 to use normal or to use the t distribution. Then we will determine the type of test. And here we have a couple of options. So basically, working on a normal distribution, we can have one tail going to the right or going to the left by using only one single tail, or we can have probabilities in which we have the two tails. And basically, the decisions in order to use one tail or two tails is based on the alternative hypothesis. In the null hypothesis, we have also as always equal. So the mu is equal to some specific value. So basically, we are saying that our data is coming from a fixed distribution. And in the hypothesis, in the alternative hypothesis, we can have three options. That basically that the mu, that the mean is different to a specific value. Okay, it's not equal. That's one alternative. Then we can have a second option that says that the mu is greater to a specific value. And the last one is that it's less than a specific value. So that is not equal, greater than, or less than. So we have three different options. Okay, so in the case of a one tail, so we'll have always when it's greater or less than a value. So basically, when we're using in the alternative hypothesis, a greater than or less than value. So in all of those cases, we will have only a one tail hypothesis testing. And the direction of the sign will tell us if it's right or less. For example, greater. So the greater than signal is pointing to the right. So in those cases, the critical region is going to be in the right. So we are working with the right tail. If we have a less than sign, so that sign is pointing to the left. So that means that we are facing a case in which we have the left tail the problem. And if the situation in which we have just the not equal, so the different, so in that case, that implies a two-tail hypothesis testing. Okay, so that's the rule to decide if we are working with the right tail, one tail, right tail, left tail, or we are working with two-tail hypothesis testing. Okay, just look at the alternative hypothesis. That will give you the clue. Then the fourth step is pick a significant level and a critical value. So basically, usually for this type of problem, that's gonna be a set, that's gonna be given. But in real life, you have as a user, that's gonna be a user input. You are as a user, you have to decide on the confidence level, and basically that's gonna be decision based on how risk adverse you are. So for us, that's going to be given. So the 1 minus alpha is going to be given. So then we will know the value. And based on that, we can compute the critical value, of course, using the C or the T distribution that was previously defined in step number 2. Then we will compute the test statistics, having all the information. Remember that test statistics is just a formula that we need to apply, depending if we're using a normal or a t-system distribution. And finally, we will be comparing the test statistics with a critical value, or alternative, we can compare the p-value with the specific alpha value. So that's basically the six steps that you need to follow in order to conduct a hypothesis testing. Let's go back to our example. I know before that, let me just how do we make the decision? So remember that the decision that we are trying to make here is if we reject the null hypothesis, or alternative, if we don't have enough evidence to reject, in that case will be we fail to reject that hypothesis, that null hypothesis. So when do we reject the hypothesis testing? So basically, we're going to be computing a critical value in one of the steps, and this critical value will define what is called as critical region. And this critical value is computed or depends on the alpha value. So basically, the alpha value is going to be the area under the cube, and that area is limited, is bounded by the critical value. And based on all the information that we have from the sample, we'll compute the test statistics. So for this particular example, what you are seeing in the screen is that the test statistics is greater than the critical value, meaning that the test statistics is inside the zone, within the zone that is called critical region. If the test statistics is within this region, lies inside this region, in that case we will reject the null hypothesis. In other words, if the test statistics is greater than the critical value, we can reject the null hypothesis. Okay, but of course this only applies when we have a one-tail, right-tail hypothesis testing. If we are, for example, in the left-hand side, if our alpha, if our critical value is less than 0, so the comparison is gonna be different, right? So in that case, if the test statistic is less than our critical value, in that situation we can reject our null hypothesis. So that's why it's very important to identify if it's right tail, left tail, or two-tail hypothesis testing. Similarly, or alternatively, we can use the p-value. So the p-value is similar to the alpha in the sense that is an area under the curve, but in this case, this is the area that is limited by the test statistics. Okay, so for this example, is all this green color area. So to compute the p-value, what we need is the test statistics. First, we compute the test statistics, and based on this value, I'm going to be computing the area that is under the curve, limited by these test statistics. So the criteria here is if we're using, instead of using the critical value, if you're using the p-value in order to make a decision, so basically we'll compute the test statistics, then the p-value, and that p-value will be compared with alpha. Okay, for a right-hand side or right tail, so basically you will see that the p-value now is smaller than the alpha, because the test statistic is to the right of the critical value, is greater than the critical value. So the decision here is if the p-value is lower than the alpha, if the area that is related to the value is lower than the alpha, we can reject the null hypothesis because the test statistics will fall within the critical region. Okay, so same criteria or similar criteria, and the decision is going to be the same. So we don't have to use both. We can just decide if we're going to be using the critical value of the p-value, because the decision that we are making using the both approaches should be exactly the same. So these are these are our question 2. In this case, the question 2, the two hypotheses that we are defining is the null hypothesis that the method doesn't have any impact. So basically that the delivery times are exactly as before. In this case, we are saying that the mean of these times exactly as the previous one. So basically what we are saying here is that the mu is equal to 20.31. That was our old mean. And H1, we are saying that is different than before. We are not saying that this method helps us to reduce the delivery time or to increase the delivery time. We're saying that the new method is just providing different delivery time. So that's why we are using here an hypothesis, alternative hypothesis that's saying that the mu is different to 20.31. Okay, so in this case, since we're using this alternative hypothesis, we are talking about a two-side tails. Okay, two-tailed tails. And we're using, since the sample is 138, we're going to be using the normal distribution. Okay, so let's now talk about question 3. Question 3 is a similar situation. Again, we are aiming to compute here or conduct a hypothesis testing. The only difference is that before we were using positive and negative values. So we have, remember that our data points are differences between the promised delivery date and the actual delivery date. So some of them were positive and other values were negative. But in this case, so the analyst that was conducting this analysis thought that it would be a better idea if we just include positive values. So we were removing the negative values and we just kept the positive values. And in that case, we get a sample of 12 values. And the main difference between the previous one is, of course, the data set, but also previously we were given with the mean and the standard deviation of the sample. For question 3, you have to compute those values. And again, you can use Excel in order to compute. For the mean, use the average formula, and for the standard deviation, use the sample standard deviation formula. Because remember that we are working with a sample of n observations. The previous mean, so the old mean without implementing this new method, was 6.16. So, and that's going to be what we'll have in our null hypothesis and alternative hypothesis. The null hypothesis is that basically is equal or before, less or equal than before, and the alternative hypothesis is going to be that is greater than before. Okay, we are using a sample size of 12 items, so we're using the t-distribution. Remember that the decision is if our sample size is less than 30, use the t-distribution. And finally, is one tail test because our alternative hypothesis is greater than, and it's going to be a right tail problem. Okay, and with that, let me stop sharing. So that's what we have prepared for you for today. So we have still some time, and the intention for this time is to have any question that you may have. Okay. In the meanwhile, why don't Akash, maybe you can start working on some of the questions that we have frequently seen in the discussion forums.
Sure. There's a few questions in the problem. Actually, you can start with those. One of them is asking for the prediction interval.
Yes.
The student used inverse normal of 0.05 and 0.95 for lower and higher bounds, and you got a slightly different answer. He or she wants to confirm if this formula is also correct.
Okay, so he's using 0.05.
0.05 and 0.95 in the inverse normal function.
Okay, so basically you can do that. That's not a problem. So you can use, so for this case, we have 1 minus alpha that was 0.90. Okay, so alpha over 2 was 0.05. Okay, so you can use that. However, if you're using, for example, the norm inverse, that should be of 0.95. That's what the learning is using,
yes,
right?
They use 0.05 for the lower bound and 0.95 for the higher bound.
Okay, so you can use for 0.95 for the upper bound, and you will get, so the C is going to be a positive value. For the left-hand side, you're using 0.05.
Yep.
Right, so that's correct. You can use that, but however, you're gonna be getting a negative value. because it's left-hand side. Remember that the standard is the standard distribution has a mean of 0. So all the values that are lower than 0 are gonna be negative. Okay, so you're gonna be getting a C that is gonna be negative. So in your formula, so you don't have to use minus minus. So basically your formula is gonna be X and the value of C. So that's so the negative value is already incorporated in C. So you don't have to have minus C. Just put X minus the value that you are getting. Okay. So short to be sure in your answer, yes, you can do, but be careful with the sign that you're using for the lower bound.
Perfect. Thank you. There's also another question, more logistics related.
Yep.
So the student started the course 10 days back and is currently the statistics module, but has 30% of the statistics module left and other modules, and is asking whether they should continue with the course or register again. I think if they can devote the time, the remaining month or so towards the course, I think they should be able to finish it. So as you said, even if a student starts all the modules today, it takes like 12, 13 hours per week. So since you're already in module 3, as long as you can devote at least like, I don't know, 7, 8 hours a week, I think, yeah, you should be able to complete the course in time and get ready for the final.
Correct. So I think you still are on time. However, you have to dedicate so many hours a week. As I was saying at the beginning, so you have to dedicate maybe 12, 13 hours a week in order to watch all the material, do all the practice problems, and get ready for the final exam. Okay, so you still have time, but you have to commit to have to be very committed to the course.
Perfect. There's another question about the previous live event. They're wondering if there's a recording somewhere they can watch since they missed that.
Okay.
I'm not sure about.
So we will make it available. I think we have the recorder, and same thing for this live event. So we'll get uploaded. So you will have access to this material.
Perfect.
Definitely.
And there's also 2 questions that came up regularly for this module, so I thought I'll just cover them really quickly. The first one was the standard deviation. To calculate a standard deviation in Excel, what formula should you use between stdev.p or stdev.s? So basically, if you're calculating, it depends on what the question is asking for. If you're calculating the sample standard deviation, you would use stdev.s as the sample standard deviation. And if you're calculating population standard deviation, you would use stdev.p. Okay,
awesome. So basically, so look for the clues in the problem. Okay, they will tell you if you're working with a population or you are working with a sample, and you can use the formula, the Excel formula accordingly. But what happened in real life? So in real life, so what will happen is you can still use you will see that when you have more than 30 observations, so both formulas will provide very similar results. Okay, so but if you have less than 30 observations, there is some difference between them. So general rule in real life use cases. Okay, if you have less than 30 observations, use the sample, the S formula, and if you have more, you can use either of them.
Perfect.
Okay.
There's one more question from one of the practice problems. This is practice problem number 2, part 2. And they're wondering in Excel, why do we use the inverse normal function of 1 minus alpha over 2 instead of just the inverse normal function of alpha over 2? And the answer to this is that since you're using a normal distribution, the critical value that you have reflects the percentage to the left of the tail. So this is why you would need to get the percentage for that value. So it would be 1 minus alpha over 2 in the normal inverse function.
Okay, great. So if we don't have more questions.
Yeah, there's a few more that came up. So are there any problems available to practice after completing those included in the course? So as Sergio mentioned, that there will be a practice exam the week before the final, which will someone give you the opportunity to do these problems in a timed sort of manner. So these are the extra practice problems we have that can help you prepare for the final exam.
Yeah, and that practice exam is gonna be taken, or the problems that gonna be contained in that practice exam is gonna be based on previous exam of SC0x. These are real problems that we use in the previous runs of SC0x.
Perfect. And the other question is, will the exam have the same sort of same format of questions as we have in the exam prep sections? So yeah, more or less, yeah. So the final exam reflects all the material and type of questions that are covered through the whole course. And again, the exam prep or the practice exam that's going to show up the week before the final exam, I think that'll be a great opportunity to somewhat understand how the final will be structured and do it in a timed sort of environment so you can prepare for the final exam.
Correct. Okay, so please don't miss the opportunity to do this practice exam.
Sure. The next question is, apart from the quick questions and the practice problems, are there any more practice questions available? So yeah, as I said, the practice exam is there. The exam prep section will be there. And yeah, you can also revisit, like once you're done with all the 5 modules, you can also revisit all the old modules and try to review for the exam. I think those will be the best sort of way to prepare for the exam. The next question is, are we going to have multiple attempts in the final exam as we do during practice? So I think, as far as I know, it's 2 attempts per question in the final exam, unless otherwise stated. So for some of the yes, no type of questions, there may only be 1 attempt, but most of the questions have 2 attempts, but not 15 as they are in the current module test problems.
Yes, so only 2 attempts. However, you won't receive any feedback. So basically, you won't see the check or the wrong marks. So basically, you won't know if you are right or wrong. So basically, the second attempt is just in those situations in which you identify mistakes. So maybe you made a mistake in your calculation and you want to input a new number.
Yeah.
So that's when the second attempt applies. It's not because we're not providing immediate feedback.
Yeah, so we will provide no feedback. So as you said, just to clarify again, it's just if you made a typo while entering the problem, entering the answer into the solution box, or found an answer when you redid the calculations or something. So you can just correct your answer, but even after the first attempt, we won't tell you if it's right or wrong.
Correct. And also, but you will see a similar situation in the practice exam. Okay, so you will be immersed in this situation. But of course, for the practice exam, we'll provide the answers after we close the practice exam. So you will see what will be the right solutions, but not during the test. During the test is going to be exactly as the real test is gonna be.
Perfect. There's also a question of how many questions in total do the students expect on the exam. I think it's 4 problems, if I'm not mistaken. Yeah, and the practice exam that'll show up will be somewhat reflective of the length of the actual final exam. So yeah, I guess it's good that you can have the practice exam in a timed environment to make sure that you can work through these problems fast enough under the time limit.
Correct. 4 problems.
Perfect.
And 4 hours to complete it.
Are they allowed Wolfram Alpha during the exam?
Yes, you can use any software that you want.
Yeah.
So you can use for the optimization, for example, any software that you may have, Excel or other softwares, and also to make calculations, you can use it.
Yeah. So I guess the only big constraint is that you have to work independently. You can't work in groups or anything like that. But yeah, you're free to use any software you would like.
Correct. But it's your responsibility that makes sure that the software is working properly during the time, especially if you are using some cloud-based software. Okay.
Perfect. I think there's no more questions for now.
Okay. Awesome. Any last advice for them, Kash?
Yeah, so as Sergio mentioned, I think we're starting to slowly approach the final exam day, or the start of the final exam. So I guess now is the time, if you haven't dedicated a lot of hours, I guess now is the time to put in all the hours and get all the modules done, get the exam prep section done, do the practice exam, and yeah, just good luck to everybody. And yeah, we look forward to working with you over the next live event also.
Okay, awesome. Please don't forget that we have a last final event in a couple of weeks. All the information about the dates and the content is going to be in the platform, in the course. Please try to solve the problem for the last live event prior coming to the live event, and use this time to ask any questions that you have about that model, which is going to be optimization. Again, I mean, final remarks. I think we believe in you. We are pretty sure that you can do it. It's just a matter of time and practice. Please dedicate a proper amount of time and practice to master all the concepts that we have in SC0x. And we are here to help you. So please, if you have any questions, use the SC0x help or use the discussion forum. So we are here to help you to get ready for the final exam. Okay, and that will be all for today. I'm going to be posting this live event in our course, and you can watch it later as well. Okay, see you next time.
All right, thank you. Bye-bye.
Bye.